Hey, Marcus House with you here. Today we are going to try to recover a SpaceX Falcon 9 Stage 2. We're going to return it from orbital velocity, just like Elon Musk tweeted back in mid-April when he basically tweeted out SpaceX will try to bring a rocket upper stage back from orbital velocity using a giant party balloon and then land on a bouncy house. Now, there has been a massive amount of speculation around what this all might mean. I think we've got a fair idea though. There's been a huge number of discussions around Reddit and various forums. I think it's fairly clear that SpaceX will attempt to use some form of inflatable heat shield, and of course the general idea is that the heat shield would sit on top of the Stage 2 near the payload adapter. So what I thought that we would try to do is simulate this. So we're here with a Falcon 9 replica using the Kerbal Space Program simulation, and as our payload today we have got a fairly conservative satellite. It's around 9 tons in weight, so certainly not the maximum that the Falcon 9 can handle, and we're also going to be recovering our booster stage here on the drone ship, so we do need to leave a little fuel in the tank just so that we can come back and recover that stage. So we're ditching that there. Just we'll power up just a little further. When we hit around 100 kilometers in altitude, we are going to deploy our fairings here. This is around the time that they would deploy them in real life as well, so there they go there. And while we are watching the second stage get up to orbital velocity, we can also pull out our booster footage so that we can watch this at the same time, very similar to what we would see in a real launch. So you'll notice there we've done a very small correction with our booster. The central engine there is just turned on to minimum thrust. This is going to mean that we can accurately target our drone ship. For those of you that play the Kerbal Space Program game, the stock game, you will notice here that we have got all of the RealismOverhaul mods installed. This means that our orbital velocity requirement is exactly the same, or very close to exactly the same as what we see in real life. And I must admit I was a little skeptical as to whether we could actually keep a Stage 2 facing a forward direction, a prograde direction, as it was re-entering using an inflatable heat shield. So this is going to be a lot of fun trying this out. Our second stage here just approaching 4,000 meters per second. We need to get to around 7,800 meters per second to get to orbital velocity, so still quite a way to go. Meanwhile, our first stage booster is coming up over the top of the drone ship and it's about to hit the atmosphere quite hard. We are just turning on our RCS, our reaction control systems, at 70 kilometers in altitude, and just about to do our re-entry burn here. Just going to bring our velocity down to around 1,200 meters per second. As we hit that mark, you'll notice that the textures on the Falcon 9 rocket quickly switch there to the burned texture. That's a nice little feature of this mod here. Now, this is where the grid fins on top of the Falcon 9 really start to play a huge part. What they can do is control the vessel and steer it down towards the drone ship. You'll see it curving back and forward, trying to get right over the top of that drone ship. And as it wobbles back and forth, it's also reducing velocity. Using only atmospheric drag, we've already dropped right down to 600 meters per second, just a few hundred meters per second to go, and starting our landing burn using 3 engines, switching quickly to the central core engine. This engine is more powerful, even at minimum thrust, than the weight of this vessel, so we need to touch down nice and gently, and there we go, touchdown, with just fumes remaining in the tank there. Of course, the new Block 5 upgrades are fairly numerous. There's a whole bunch of new additions, which is going to make the Block 5 version of the Falcon 9 much more reusable. Titanium grid fins, of course, are one of the key features there. Quite expensive, so they don't want to lose too many of those. New landing legs have got the ability to be retracted by the ground crew instead of them having to be completely removed after landing. So we have just hit orbital velocity there with our Stage 2 there at 7,800 meters per second. We're going to decouple our payload here, our small 9-ton satellite. So a few quick checks on our payload there. We're going to extend out the solar panels. We've got 3 solar panels attached to the side of this thing. Out they come there. This satellite has got enough fuel, enough delta V, to be able to get right up to a geosynchronous orbit all by itself if it needs to, so no problems there. We're going to now switch back to our second stage, and we're going to now try to come and bring this into land. Now, the wonderful thing about the second stage is that after that payload has been decoupled, the delta V is actually quite considerable. Even though there's only a tiny amount of fuel left in the tank of the second stage, just a few seconds of burn time can wipe off hundreds of meters per second. And all we really need to do here is around a 6-second burn, and this is going to not only reduce our velocity enough to re-enter the atmosphere, it's going to do it in a targeted way, and it's also going to slightly change our inclination to meet back up where our launch facility is. In this attempt today, I'm actually going to be attempting to land on land. But I think in real life what they would actually be doing is landing out on the ocean and catching the second stage with some sort of boat, net, bouncy house type thing, which is probably only in the dreams of Elon Musk right now. I'm not sure what that's going to look like. That's not really the important part, I don't think. It's going to definitely be possible to catch it as long as it can re-enter the atmosphere. So just completing that re-entry burn there, we are now on a fairly good trajectory to land on the land just near Cape Canaveral, which is where we took off. So we've done one full orbit, and we're now going to just time accelerate until we start to re-enter the atmosphere. That is at around 140 kilometers in altitude. So before we do that, we're going to just eject the covering from our payload adapter there, inflate the heat shield, and now the trick is to keep our craft perfectly pointed towards the prograde marker on the nav ball. We're going to be doing this with the reaction control systems. We're going to actually turn on the fine control here just so that it's not using a whole lot of nitrogen. You can see from the panel up in the top right, the nitrogen slowly being depleted there as we keep our vessel pointed correctly. So I'm just making sure that everything's nice and stable here. We can actually switch back over into map view just to see where we're targeted to land. You can see we're just here next to Cape Canaveral. The red X there is where we're targeted to land based on our current trajectory. So very, very close there. Now what I found as we were coming in here was that the vessel would want to sort of drift and rotate up in the high atmosphere, up around 100 kilometers. It was quite difficult to keep it stable, but as soon as we get into the thicker parts of the atmosphere, the actual shape of this inflatable heat shield, and all inflatable heat shields like this, actually keeps it centralized very well without using any reaction controls at all. So just coming down to around 70 kilometers, this is where the atmosphere really starts to heat up, and you're going to start to notice some flames licking off the side of the heat shield here. We're going to get a little bit of a trail going, but what you will notice if you look at the nav ball in the bottom left, that the G meter is slowly increasing there, and you can see just how fast our surface velocity is being wiped off. This is a very, very large heat shield with a massive surface area, and just remember, our fuel tank here is basically empty, so what this means is we can reduce most of our velocity before we actually even hit the real thick part of the atmosphere. We're at 43 kilometers of altitude now, and our surface speed is down under 2,000 meters per second. So this is fantastic. What we can basically do is deflate the heat shield. This is going to make the vessel quite bottom heavy because there is quite a lot of mass in the lower part of the vessel with that engine. So that gives us a natural flip here towards a retrograde direction of travel. Now we do have a little fuel remaining in our tanks. I believe in real life they would probably just jettison that at this point because we want this to be as light as possible, but just because it's Kerbal Space Program and I can, let's fire the engine up, do a small burn just to deplete all of our remaining fuel. There we go there. I'd forgotten to turn gimbal back on the engine, so yes, that was giving me zero control. Nonetheless, we have now burnt off all of our fuel. That is as light as our vessel is going to get. We're going to jettison the heat shield. There it goes there, right in towards the camera, and we're going to now deploy 2 sets of parachutes, which is going to mean that we can actually fall down very, very slowly. You'll see we're still 11 kilometers in altitude. Now, technically, we could have deployed these chutes even higher just to give us more time to position whatever apparatus SpaceX dream up. underneath the vessel. Now, like I said before, I suspect they will actually have this occur out in the ocean just to minimize any damage or inaccuracies in the trajectory on the way back in. But just because I could, I thought, well, I can actually touch this thing right down on land because it is descending at a surface speed, a relative speed of only 5.5 meters per second right now, and the atmosphere is still going to get thicker again. So it actually took a lot of time to wait for this to get back down. So I'm skipping over all of the footage. You can see in the top left, I've actually time accelerated the descent here to 4 times speed, and I'm speeding up the footage as well. So we're now down to a surface speed of 4.6 meters per second. So let's assume there is a gigantic boat with some sort of massive bouncy house to catch this thing, or some huge net. It's got plenty of time, many minutes, to actually get down right underneath this vessel just to catch it as it lands in the ocean. But just because I can, and not that this would work in real life, we're going to touch this thing down right on the engine bell. And there we go, touchdown there at only a few meters per second. Now, obviously there are a bunch of technical challenges to overcome here. They need to pack parachutes into this thing. They need to pack a heat shield onto this thing in a way that's still going to allow the payload adapter to work. Those challenges to me don't seem too insurmountable considering what SpaceX has already accomplished, so I'm looking forward to seeing what awesome stuff they invent to try to make this happen. So I hope you enjoyed that video. Please do take a second and hit that like button. All of your support is just awesome. If you have any questions for me, please do whack them down in the comments below. If this video has earned your subscription, welcome to the channel. And for all my existing subscribers, thank you for being so awesome. In the title in the bottom left today, we have my gravity-assisted mission out to Jupiter from a Falcon 9 launch. In the top right is my latest video, and in the bottom right, a video that YouTube has selected from my channel just for you by some crazy little robot. Thank you all for watching, and we'll see you all in the next video.